Kids, we got a problem. How are we going to solve this quadratic equation? You're like, oh, come on, Miss Now. I got lots of other problems to worry about, but I'm being serious. Mathematically, how are we going to solve this quadratic equation? We've learned so many things that sometimes, well, to be honest, we don't know what we learned. But I want you to know what you've learned. If you go back to the beginning, one of the first things we did was we factored. Factoring is nice when you can very easily split a trinomial into two binomials. The problem here is that this one's not so nice. Yeah, I mean, I'd have to use 7x and x, and then good luck trying to find numbers that work out to be, or multiply to be negative 15, but work out to be 14. Actually, I'm going to be honest with you, you're not going to be able to find them. I mean, I can't do anything that would somehow mix and match numbers that would multiply to be 15. Yeah, you can't factor the problem. So that option is sort of out. There is another way. It's called the British method. The British method is basically a way to try to figure out these factors. I'll show you that that's not going to work either. Why isn't it going to work? Well, the truth is it's not going to work because you're not going to be able to find two numbers that multiply to be negative 105 but add to be 14. Yeah, the reason you can't do that is because, again, the problem cannot be factored. Now, if you're like, yeah, the problem can't be factored, so I guess that means I can't solve it. Well, we did have another strategy that we tried. It was called completing the square. Now, completing the square is tricky because in this problem, you got to factor. And once you factor, then you got to fool around with trying to make the numbers work with what I got here. I mean, I got to try to fill in the number 1. That is the number 1 squared. But remember, I didn't really add 1. I actually added 7, so that means I had to subtract 7. And again, this is looking kind of tricky. Now, I'll be honest, we probably could continue with this strategy, but I'm kind of feeling that most of you would say, nah, I don't really want to do that. So what am I going to do? Well, what we're going to do is we're going to learn another method. It's called the quadratic formula. The what? The quadratic formula. You see, the quadratic formula can work for any quadratic equation because all we're going to end up doing is plugging in a, b, and c. And we're going to plug in a, b, and c into this, what will become not a strange formula, but this formula where we end up needing the opposite of b plus or minus the square root of b squared minus 4ac. What's that you say? You've heard of this before? Yeah, I mean, you should have been introduced to this in algebra. Now, if you weren't, okay, we're going to have to figure it out today, but yeah, this is the quadratic formula. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And the a, b, and c, well, they just become the numbers from your equation. Oh, look, it's the equation that we were trying to mess around with as a little intro. So what do you think? We've got A, we've got B. Make sure C is negative 15. You want to see if we can plug them into the formula? Okay, the nice thing about this formula is, well, it's a formula. That means that it's always going to be the same, and I can plug into it. Let's do it correctly the first time. It's the opposite of B, so that's the opposite of 14, otherwise known as negative 14. Plus or minus the square root of b squared. Well, there's 14 again. It's squared. Minus 4. 4 is always there. A is 7. C is negative 15. And it's all over 2a. So all over 2 times 7. Now, I'll tell you, any student that works out this quadratic formula, it always becomes the same thing, trying to figure out the part that's underneath. The part that's underneath has a special name. It's called the discriminant. You don't really have to worry about that too much right now, but we need to do the order of operations. So that would mean 14 squared. Sometimes students will write these numbers down separately. I encourage you to do that. And then what do we got here? 4 times 7 times negative 15. So that's going to come out to be negative 420. Now you'll notice that I kept the subtraction sign, but I also have a negative sign from the 4 times 7 times negative 15, which ultimately is going to cause me to do a little plus plus. And now I think I'm ready to do some more simplifying, where I end up with the number 616. That is the square root of 616. By the way, 2 times 7 in the bottom is 14. Having fun yet? Well, I'll tell you, the number 616, that is the square root of 616, it's kind of a special number. If I wasn't showing this to you, I wouldn't be giving you the full truth. You see, we can actually simplify the square root of 616 because there's a perfect number inside of it. It happens to be just the number 4. That's kind of nice because that's like your first perfect number. And yeah, do you remember simplifying square roots? Well, it's part of algebra. It's still part of algebra. So I'm going to pull out that 4, but when I pull it out, I do its square root. So I end up with 2. It leaves behind 154. That is the square root of 154. So I got my negative 14. I got my plus or minus. But now I have a little simpler 2 root 154. And, well, the rules of fractions would say that I can and should divide both of these by 4. That is, kind of do like a heart method. That gives me negative 1 nicely with the 2 14s. And 2 over 14 just reduces to be 1/7, the square root of 154. Now, that kind of answer, well, I might say can only be found with careful use of the quadratic formula. Yeah, you weren't going to get that answer from just a nice little factoring problem. Quadratic formula. I didn't make it up. If you take trigonometry next year, we will kind of prove to you where it comes from. But I'll share with you that there's some people that are so excited about it that they've sung some songs about the quadratic formula. Like this one. Looks like we got a little VRBO ad.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Of b squared minus 4ac all over 2a.
What's the problem? That's not quite your style. Maybe this one's a little more your style.
Have a seat, folks. This class is in session. Mr. Tupac, can you tell me the objective of this lesson? Students will be able to solve quadratic equations using the quadratic formula and some simple calculations. What's the quadratic formula? Yeah, we'll get to that. But first, remove those shades and that baseball cap. The quadratic formula is the tool you use when those prime quadratics have you singing the blues. First, write your quadratic in standard form. Please be thorough. Ax squared plus bx plus c equals 0. Now we're gonna solve for x using our ABCs. So get those pencils in your hands and roll with me. Take the square root of b squared minus 4ac. Then you add it and subtract it with the opposite of b. Take the values you get, divide them by 2a. Now you're solving the quadratic formulatic way. And if b squared minus 4ac is a value less than 0, then 2 I's you'll see. Like when your ABCs equals 1, 2, 3, then your solutions are not real, they're imaginary. Is this a standard form? No, it's not. So take the number from the right side and drop it like it's hot. Now it's a standard form and it's easy to see. A is 1, B is -4, and C is 3. Now plug these values in the equation using order of operations. Please excuse my dear Aunt Sally, as was taught throughout the nation. And with careful calculations, X is 3 and 1. Well, I got 6 and 10. Come on, son. How'd you get A equals 1? Ain't no number in front of X. Please tell me that you're kidding, cause I'm about to be vexed. That question shows just how little you pay attention. In fact, you just earned yourself a lunch detention. Lunch detention? Nah, go ahead with that, man. I gotta see my ladies at lunch, player. I gotta see my ladies. Yeah, I got some ladies for you. I'm gonna introduce you to them at lunchtime. They go by the name of Arithmetic and Algebra. You know what I'm saying? Player. You have the answer to number 2? No, I have a question, but please don't get mad, but it's not about the lesson. Can I be in your video? I can sing and I can dance. I know I'll be a star if you give me a chance. Well, first of all, young lady, that question's way off task, and it seems you're on a mission to derail my class. But I'm gonna get you back on track with some crafty navigation and bring you to the board for this quadratic equation. So the discriminant is b squared minus 4ac. It lets you know the types of solutions there will be. When it's negative, that means you have 2 imaginary solutions. When it's 0, that means 1 real is the conclusion. And when a discriminant is a value that's greater than 0, then find 2 real solutions and you'll be a match 0. Root of b squared minus 4ac. Then you add it and subtract it with the opposite of b. Take the values you get, divide them by 2a. Now you're solving the quadratic formulatic way. And if b squared minus 4ac is a value less than 0, then 2 i's you'll see. Like when your ABCs equal 1, 2, 3, then your solutions are not real, they're imaginary.
Okay, well, do you feel like singing and dancing a little bit about because of the quadratic formula? You sure can, but I want you to be able to solve a quadratic equation like he said that, well, that is prime. That really means that you can't factor it. And, well, you still need your equation to be standard. That is, you need it to equal 0. So when you're ready to look at this second problem, yeah, we got a problem. It's this 20. I forget quite what he said. Move it to the other side because it's hot, but you got to subtract 20 and end up with a more standardized equation. So we always want to have our A, B, and C on the same side. We always want our equation equal 0. Are you ready to try one? Okay, most of the time students, they've seen one, they're ready to try it on their own. It's just time to plug in A, B, and C. So how's it go? Opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. Yeah, the Pop Goes the Weasel is a little more what I can handle. I'm not going to try to rap that song. Now, you got to do this. Don't make sure that you're not just watching me do it. You got to do the order of operations that's taught across the nation. So I've got 121. That's 11 squared. And then 4 times 4 times negative 20. Okay, well, listen, that's going to be, there's always a minus sign, but that's going to come out to be negative 320. So, yeah, I kind of have like 2 negatives here again, which ultimately causes me to do a little plus plus. So I end up with negative 11 plus or minus the square root of 441 all over 8. Now, the square root of 441, before you freak out, it's actually already a perfect number. In other words, I can do the square root of 441 on my calculator and get 21. So what's happening here is because my numbers are working out to be integers, I can and I should now split this problem further into its 2 values. Now, what do I mean it's 2 values? Well, listen, one of them is the negative 11 plus 21 value. What's negative 11 plus 21? I'm pretty sure that's 10. By the way, it's still over 8. The other one is going to be my negative 11 minus 21. Negative 11 minus 21. Oh, that's going to get like more negative, so that's negative 32. By the way, it's still over 8. So what I did here was I literally did negative 11 plus and minus 21. Okay, and well, 10 over 8, if you reduce it, usually we don't turn it into a decimal. If you just reduce it, you get 5/4. And negative 32 over 8, oh, that just works out to be negative 4. Okay, remember, these are actually the solutions to that problem, even though we found them using a different method. It's called the quadratic formula. Nice thing about the quadratic formula is it allows us to kind of be a little more comfortable with some special cases. Listen, if I hadn't told you the problem was special, you would still jump in head first. You would make the equation equal 0. I hope that 11 is now on this side. And, well, again, you would jump in here. The opposite of negative 6 actually is positive 6. Still continuing business as usual here. B squared, 4ac, and it's all over 2a. Again, the a is the number 1. Now, it's time to be a little bit more alert because I notice I'm going to get 36 minus, there's always a minus sign there, minus 44. Why does that catch my attention? Well, 36 minus 44, that's negative 8. Really, the square root of negative 8. And I don't know if you caught it in the video, but when you get a negative discriminant, that is a negative number under the square root, well, you're not going to end up with a real solution. Now, in a few months, or maybe, in a few months, we're going to talk about in a few weeks, we're going to talk about what's called an imaginary number. But right now, we're just going to say, hey, you can't do the square root of a negative number. Not in the real world, you can't. So there's no real solutions. In other words, no solution. And we can even mark that with the no solution symbol. So that's what happens when you get a negative under the square root. And it's kind of a special case. How about this problem? It doesn't really look super special. Let's find out what the big deal is. Looks like I've kind of got the same thing going on here. It's always the same thing. It's the opposite of b, plus minus square root of b squared. Always a 4, a, and c, all over 2a. A happens to be the number 4. That's why we see that a couple places. So order of operations, what do we got here? 64, that's 8 squared. And 4 times 4 times negative 1 is negative 16. By the way, if you're putting that in your calculator, okay, I'm fine with that as long as that you're producing the correct answer. In this case, we should be getting 80, but it's really the square root of 80. So, the square root of 80. Now, to kind of catch your attention, you got to kind of wonder, is there a perfect number inside of 80? Well, I think there is a perfect number inside of 80. 80 is the same as, now you got to run through your perfect numbers. 4 is a perfect number. What's the next one? 9, 16. Oh, we just got it. There's a 16 inside of 80. Okay, when I say that, I mean there's a number that you can multiply by 16, and it indeed is the number 5. Now, what I can do is I can actually take out the 16. When it comes out, it becomes the square root. In other words, it comes down to the number 4, but I leave the 5 behind. So I get 4 root 5. Now, really, the only thing that's special about this problem is that it just has a little bit more simplifying. So we took the square root of 80, and we changed it to be 4 root 5. I still have my other numbers here. And, just like I actually did in kind of the intro problem, this type of problem requires us to do like a heart method, negative 8 divided by 8, and then 4 divided by 8. We basically end up with some smaller values. So, yeah, we'll say that one's special because it had some simplifying. Hey, the quadratic formula allows us to do some you might say some more interesting application problems like this. The product of two consecutive odd integers. That sounds a little bit mathy. Here, let me help you. If you've never seen one of these, one of the odd integers can be x. So we'll say it's like the first integer. Now, it's an odd integer. We don't know what it is, but we'll say it's x. Now, what would my next integer be? Think about it. If x is an odd number, the next odd number has to be 2 units away. So that's going to be like my second odd integer. Now I've got an x and I've got an x plus 2. It says the product of these two, a product is a multiplication, so the product of these two has to equal 99. What's this problem got to do with the quadratic formula? Well, it's got a lot to do with it, because when you distribute, when you kind of like simplify, you discover that you have a quadratic equation. A quadratic equation is just an equation with an x squared. And, well, quadratic equations like to equal 0. So even though we've got that strange 99 over there, I'll just subtract it from the other side. And guess what I have? That's right, a quadratic equation. I could solve that using the quadratic formula, and I'll end up with my x values. Yeah, I'm going to, just to save a few minutes, I'm not going to put that in the quadratic formula right in front of you guys, but it will end up producing 9 and negative 11. What we want to understand is that that is just my two x values. That is, they're actually two different x values. In other words, I could say that if my x is going to, here, let's put it here, if my x is going to equal 9, that means my x plus 2 is going to be 11. But if my x is going to be the negative 11, then when I add 2 to that, it actually goes back down to negative 9. What you want to realize is that my two answers are either 9 and 11 or negative 9 and negative 11. If you think about it, they're both odd. They're 2 units apart, and they 100% multiply to be 99. A little different. We actually will do some more applications soon. We actually will make kind of a whole lesson out of some applications. So, I got my little alien guy back. Two methods. You say, oh no, I'm not even sure if I know how to do one method. And you're talking about two methods? Here's the good news, kids. All quadratic equations need to equal 0. So the first thing we would do, quite honestly, for either one of these methods, I'll tell you what, let's put that up here. The first thing that we would do for either one of these methods is we would rearrange the equation. Once you rearrange the equation, then you're a little bit more set to, well, to maybe factor. I don't want you to forget about factoring. It's really like one of the key strategies for solving a pretty straightforward basic equation. Two numbers that multiply to be negative 10, but add to be positive 3. Yeah, I mean, that's just x plus 5 and x minus 2. And then once I have those factors, I know it's almost too easy. You have your two answers. Okay, hey, that method is great. It works 100%. You definitely want to realize from today's lesson, though, that we have a new method. It's called the quadratic formula. It's the opposite of b plus or minus square root of b squared minus 4ac. Now, if you're saying, yeah, but do I really need to do this? Well, I mean, you don't really need to. We already found the answers over here. But the point is that, well, we can get the same answers. And you want to be able to confirm that you too can do that. What are we going to get here? 9 and 40. Ultimately, you're going to add those together because we have two negatives. So you're going to do the square root of 49. Oh, good. The square root of 49, that works out perfectly to be 7. Now, when you get to this step, you want to realize that I've got negative 3 plus 7. Now, negative 3 plus 7, that's actually going to be 4. It's still over 2. And then I also have negative 3 minus 7. Oh, that's going to be like more negative, negative 10. Still over 2. Guess what's true about these two numbers? They're right at the corner of the screen, but they equal 2 and -5, which are the same numbers that we found with the other strategy. So yeah, we can solve this with two methods. When you do the homework, I want you to solve with the quadratic formula until you get down to number 7, where it's the same thing. We're trying to get you to use, again, two different methods.